Hello everyone, my name is Gajendra Deshpande and today I will be presenting a talk on securing Django web applications. So in my talk, I will briefly discuss about the security aspects of Django web applications, penetration testing of Django web applications, then overview of OWASP, top 10 risks and strategies and configuration settings to make Django web applications secure for each of these OWASP top 10 risks. Then finally the two applications Djangohunter and Django Goat projects. So let us first look at this website. It is djcheckup.com where you can enter the Django site's URL and check for the presence of vulnerabilities. Now we checked for one website and it says that there is one recommendation found, but on this page the recommendation is not visible, but you can see here if there are any uh, errors, then that will be displayed in the red color with the thumbs down symbol. Otherwise, if there are no problems, then it will display thumbs up signal symbol. Now this is a settings.py file which is very important. So when you are developing the applications, you can set debug parameter to true because you want to see the errors when you are developing your application. But once you develop the application, you need to uh, deploy this application into a production environment. In that case, you need to set debug equal to false, because in production environment, if you set debug equal to false, then your application will become vulnerable to attacks because it will reveal the system information. Then second is that you need to keep the secret key secret. So we know that there are top 10 vulnerabilities defined by OWASP. OWASP stands for Open Web Application Security Project. So these are injection, broken authentication, sensitive data exposure, XML external entity attack, then broken access control, security misconfiguration, cross-site scripting, insecure deserialization, using components with known vulnerabilities, insufficient logging and monitoring. Now, injection is the most common type of attack. So, where malicious user is able to execute arbitrary SQL code on a database. So, this can result in records being deleted or data leakage. So, injection vulnerabilities are present or they are often found in SQL, LDAP, XPath, or even NoSQL queries, in XML parsers, in SMTP headers, and so on. So injection can result in data loss, corruption, or even the disclosure of information to unauthorized parties and loss of accountability or even denial of access. So it can also sometimes lead to complete host takeover because of data leakage. Now you can also see here one example. So the first line specifies a SQL query. So where it is written the select star from accounts where customer ID equal to the parameter name has been specified. Now after the ID parameter, you can or the attacker can put the attack vector. So that is shown in the next line. So after ID, it is mentioned that R1 equal to 1. So R is a Boolean operator. So attackers use usually these Boolean operators and it is mentioned 1 equal to 1. So in this case, whatever may be the left hand side query, it is going to result into true and reveal the information. Of course, in real world, it is not so simple. Attackers need more complicated attack vectors. Now there are two functions. One is extra and second one is raw SQL, which enable the um, Django developer to write custom queries. So these are also a source of injection attack. Now the solution is perform query parameterization. So it is performed by default in Django. And whenever you're using extra and raw SQL functions, use them with caution. Then use positive or whitelist server-side input validation. Of course, it will not be able to provide the complete defense, but you can achieve the defense up to certain extent. So at least you can prevent script kiddies and beginners to perform or to succeed in the injection attacks. Then second one is the broken authentication. So we know that the attackers have access to the hundreds and millions of valid usernames and password combinations. So they usually get it in dark web. Uh, but in broken authentication, they don't need these millions of accounts. They just need to get access to the or gain access to the only few accounts. They are the admin accounts or super admin accounts or privileged accounts. So if they get access to these accounts, then they can do whatever they want. So they also occur, these authentication attacks also occur due to the continued use of passwords as a sole factor. Then application session timeouts aren't set properly. Say for example, there has to be some inactivity duration. So after say 2 minutes of inactivity or 5 minutes of inactivity, application should log you out automatically. So if it is not logging out automatically, then it will result into broken authentication, because anybody can just sit on your system and gain access to your account. Then the possible protection for broken authentication are that wherever possible, use multi-factor authentication. Okay, so you can also go for two-factor authentication, which is very, very common, where the OTP is sent to your mobile phone and the email. So you need to enter the code into the application to proceed further. Then do not ship or deploy with any default credentials. So that particularly the admin users. Then implement weak password checks, such as testing new or changed passwords against the list of top 10,000 worst passwords. You can also implement single sign-on, because the password is sent to your email or even to your mobile number, and it is only valid for a single session. Then align password length, complexity, and rotation policies with the NIST 863B's guidelines in section 5.1.1 for memorized secrets or other modern evidence-based password policies. Then limit or increasingly delay failed login attempts. So log all failures and alert administrators when credential stuffing, brute force, or other attacks are detected. Then use server-side secure built-in session manager that generates new random session ID with a high entropy after login. Then you can use these Django modules such as Django OTP and Django two-factor authentication, and also Django's user sessions for user sessions management in Django. So these modules will help you to protect from broken authentication. The next is sensitive data exposure. In sensitive data exposure, rather than directly attacking the crypto, attackers steal keys, execute man-in-the-middle attacks, or steal clear text data of the server. So while in transit or from the user's client, say for example browser or any application from the user's machine or from a mobile phone. So here the manual attack is generally required. So an application encrypts credit card numbers in a database using automatic database encryption. Then, however, this data is automatically decrypted when retrieved, allowing a SQL injection flaw to retrieve credit card numbers in the clear text. Now, if the system is compromised, the moment you decrypt the information is available to the attackers. So here the researchers are working on something interesting concept known as homomorphic encryption, where you will be able to perform computations over the encrypted data. So in this way, you will be able even use the capabilities of a compromised device. Then a system doesn't use or enforce TLS for all pages or supports weak encryption. Then the solution is one solution we have already discussed, that is the use of or enforcement of homomorphic encryption techniques, but they are highly computation intensive. More work is needed in order to make them lightweight. Now, don't store the sensitive data unnecessarily, so discard it as soon as possible. Then make sure to encrypt all sensitive data at rest. Then ensure uh, up-to-date and strong standard algorithms and protocols. Then disable caching for response that contains sensitive data, then enable HTTP strict transport security protocols, that is HSTS or HTTPS, then store password using strong adaptive and sorted hashing functions with work or delay factors such as Argon2, script and bcrypt, etc. Then if you are making some settings in the production.py file, then these are the settings which are recommended. So instead of HTTP, use HTTPS, then set most of the security parameters here to true. Then if you want to protect against security data, protect against sensitive data exposure, then you can use these Django modules, that is Django encrypted model fields and Django cryptography packages, and also Django Fortnite fields. Now, these can also be used to perform computations on the encrypted data. Then XML external entities attack. So those who have worked with markup language such as HTML, they are aware that they can use entities to print special symbols such as copyrights or trademark symbol. So the same can be used to perform the attacks. So the problem here is the flexibility of the XML language. We know that the XML allows us to create our own tags, attributes, and entities. So this flexibility itself becomes the vulnerability in case of XML external entities. So for example here, the attacker attempts to extract data from the server. In this case, the uh, attacker is creating an entity called as XXC, and he is mapping it to /etc/password file. So whenever the user or the developer or whenever the end user uses this entity, that is ampersand XXC, so he is gaining access or extracting the data from /etc/password file. And similarly, he can or she can link the entity to private network by changing the above line to the IP address /private. Then the attacker can also perform denial of service attack by potentially pointing it to an endless file. So /dev/random. So whenever the user specifies XXC, it performs denial of service attack. So to protect against XML external entity attack, you need to use the less complicated data formats such as JSON and avoid serialization of the sensitive data. Then disable XML external entity and DTD processing in all XML parsers in the application. Then implement positive or whitelisting server-side input validation, filtering or sanitization to prevent hostile data within the XML document. Then you can use XML, XSL, and XSD and DTD validators to ensure that you are conforming to the rules of the language and rules of the um, application's DTD file or XSD file. Then you can also use a tool called as Shadow Daemon, which is a collection of tools to detect, record, and block attacks on the web application. It's a free software. It supports Python language and its frameworks such as Django and Flask. Then it also supports PHP and Perl languages. The next is the broken access control risk. So here the application uses the unverified data in SQL call that is accessing the account information. Okay, so here, for example, not my account is the unverified data. So an attacker can simply force the browser to target the URLs, and admin rights are required for access to the admin page. But in this case, since it is unauthenticated, so user can directly access either page, and it's a flaw. So even the non-admin user can access the admin page. So the solution is that access control should be enforced in the trusted server-side code or in the serverless API, where the attacker cannot modify the access control check or metadata. So with the exception of public resources, deny by default. Then disable web server directory listing and ensure file metadata and backup files are not present within web routes. Then log access control failures, alert admins when appropriate, and you can also use the Django user management module. The next is security misconfiguration. So this is very interesting. So by default, we know that the frameworks such as Django or Flask, they are secure by default. But what happens here is that they also have some default settings. When the application is shipped with the default configuration, then it becomes vulnerable. Okay. So in this case, the security misconfiguration can happen at any level of an application stack. So including network services, platforms, web servers, and so on. So it comes up with a sample applications that are not removed from the production server. Data listing is not disabled on the server. So these things need to be taken care in case of security misconfiguration. So the solutions are that harden the Django. That is, don't use default settings. Remove all basic applications or unwanted applications, default applications. Then disable data listing. Then use automated scanners to identify the issues of misconfiguration. Then customize error messages to hide the sensitive information, because error messages also reveal important system information such as the operating system version, browser version, and so on. Then the next risk is cross-site scripting. So whenever you might have visited a website where it has search functionality, and in that search functionalities, some of you might have tried executing a simple JavaScript code that is alert of hello or something, just a alert function. So in that case, if alert executed, then it's a clear indication that XSS vulnerability is present. So that can be handled by uh, properly validating the uh, input field and also escaping. Now, in this case, you can see here that the attack causes the victim session ID to be sent to the attacker's website, allowing the attacker to hijack the user's current session. Now, attackers can use accesses to defeat any automated cross-site request forgery defense the application might employ. The solution is that use Django templates, which by default protect you against the majority of the XSS attacks. But there are some exceptions. We know that the recent versions of HTML and also the uh, technology such as AngularJS, they have got some different syntax where it is possible to replace this code with the variables. Now, what if this variable stores a malicious code? Okay, then we cannot do anything. It will not protect such cases. And it is also important that when you are using safe with custom template tags, the safe template tag mark safe, and when auto escape is turned off. So you should also be very careful when storing HTML in a database, especially when that HTML is retrieved and displayed. So insecure deserialization. Now, applications and APIs will be vulnerable if they deserialize hostile or tampered objects supplied by an attacker. So there are basically two types of primary attacks. One is object and data structure related attacks, where attacker modifies the application logic and achieves the arbitrary remote code execution if there are classes available to the application that can change behavior during or after deserialization. Then the second one is typical data tampering attacks such as access control related attacks, where existing data structures are used but the content is changed. Now, serialization may be used in the applications such as remote or interprocess communication, wired protocols, web services, message brokers, HTTP cookies, API authentication tokens, and so on. Then the only safe architectural pattern is not to accept serialized objects from untrusted sources or to use serialization mediums that only permit primitive data types. Now you can implement integrity checks using digital signatures, and for that, Django provides JSignature module. Then isolate and run the code that deserializes in low privilege environments. So you can run it in a kind of a sandbox. Then log deserialization, exceptions, and failures. The next one is using components with known vulnerabilities. So we know that the frameworks such as Django, Flask are by nature secure. But what happens in open source world is that there are many modules which will be developed by or which are developed by the third party developers, and they may not be aware of security standards of writing the code. So in that case, the application becomes vulnerable because these compromised plugins, these compromised modules provide the backdoor entry to the system. So the solution is that there should be a patch management process in place to remove unused dependencies, unnecessary features, components, files, and documentation. Then continuous inventory, the versions of both client-side and server-side components, for example, frameworks and libraries, and their dependencies using tools like versions and dependency checks. Then continuously monitor sources such as CVE and NVD for vulnerabilities in the components. Then only obtain components from official sources over secure links. Then use tools like Shodan and Djangohunter. So we'll see what those tools are. The next is insufficient logging and monitoring. So exploitation of insufficient logging and monitoring is the bedrock of nearly every major incident. So attackers rely on the lack of monitoring and timely response to achieve their goals without being detected. So one strategy for determining if you have sufficient monitoring is to examine the logs following the penetration testing. The tester's actions should be recorded sufficiently to understand what damages they may have inflicted. So in this case, the solution is that ensure all login, access control failures, and server-side input validation failures can be logged. So basically, employ logging and monitoring tools. There are external tools. There are lots of packages. You can just install them to continuously monitor most aspects of your application, so that this collected information can be analyzed in order to find out the possible cause for the attack or source of attack or the sequence of events which have led to the attack. Now this is a very interesting application called as Djangohunter, as we had discussed earlier. So it's a tool designed to help identify incorrectly configured Django applications that are exposing sensitive information. So for that, you need to use Python 3 and use the script djangohunter.py. You can find it in this Django Hunter repository. You also need a Shodan key. So of course, Shodan is not free, but for a nominal fee, you can get the limited features and you can test the working of Django Hunter application. And along with it, you need to also use the Google Docs, which will help you to identify the incorrectly configured Django applications. The next is Django code. So if you are interested in learning penetration testing of Django web applications, then you can install this Django code application from this repository, which is which is an intentionally vulnerable Django application, and it will help you to learn security testing. Then you can search in Google awesome Django security projects, or you can just say awesome Django security. It will lead you to the list of resources related to the Django security. And you can also refer Django security documentation for recent updates related to the security issues of a Django framework. It's a really a nice source. So in summary, since Django is a web framework and it maps to OWASP top 10 vulnerabilities, it has the built-in modules to build secure Django web applications. So security of the application and the data is not only the responsibility of the developer, the user is also equally responsible for the security of data and accounts. Thank you everyone for attending my talk.